We are now ready to begin, and I will hand it off to one of our RMI presenters to begin the webinar.
Good afternoon or good morning, depending on where you might be located. Welcome, everyone, to the Material Handling Industries Rack Safety 101 webinar. This is just one of the many educational opportunities hosted by the MHI to help bring awareness to relevant topics within the product groups that make up the material handling and supply chain industry. Next slide, please. Today's webinar is being presented by the RMI, the Rack Manufacturers Institute. It's an organization today made up of more than 30 of the industry's leading manufacturers of storage rack and related structures and accessories. I'm Nelson Cantillo, and along with my co-presenter John Crummell and our panel of experts in the field, Brian Bowles and Dan Clapp, we welcome all of you who have registered to be part of what we believe will be a very informative session. Our audience today is made up of you folks, a very diverse group of combination end users who of course utilize and procure these products, but we also have storage system specialists signed up today to participate who provide the solutions and product options available to the users. Next slide, please. So our mission here is to cover some of the basics and bring awareness to the often overlooked best practices that could compromise the safety of personnel and product in what is, as you all know, a very dynamic either warehouse environment or any facility that incorporates these rack products. So let's take a look at the more specific topics that we're going to be touching on during this program, in which our objective is to, also make it somewhat interactive so that you as participants, if you have the opportunity to submit questions, you'll do so in real time, but we will do our best to address them during the final portion of this session, as Anupam clearly stated at the beginning. So we're going to touch on the key elements of component selection and load characteristics, but we wish to emphasize that this webinar is really based on safety-related guidelines, and it's not really intended to be an all-encompassing rack tutorial. There are several resources that you will have available to you through the MHI and the RMI that can help get into the more detailed topics, but we also, of course, welcome your questions. I want to also point out that the MHI and RMI have an extensive library of those resources for those seeking more detailed information. So we're going to touch on the proper training of personnel working within the confines of the manufacturing, warehousing, or even retail environments where we see obviously a lot of storage systems present. We'll talk about inspection and maintenance, the all too often overlooked responsibility of all individuals in those, even those not assigned to a safety role within an organization, who should really be reporting any visible damage or things that appear unsafe in the environment. Changing configuration, another area of extreme negligence that is often overlooked by end users and others that walk through facilities or that work with facilities, especially new occupants of an existing facility that might already have racks. They need to be aware of those pitfalls, so to speak. Next slide, please. So I want to start with a brief overview of the RMI, an organization that since its inception in 1958 has dedicated itself through its members to come together and look for ways to improve the quality of products and storage systems sold and put into operation in the U.S. Prior to this time, there were a lot of people making racks or doing whatever they could creatively to create a storage system, but it was kind of like the Wild West out there. And so the RMI came together in order to try to formulate some standards and help to obviously increase the safety yet efficiency of storage systems. So over the years, the RMI has conducted extensive product testing and research and development that have resulted in virtually all of the technical advances that are made within the safety codes and standards community today, such as ANSI, the American National Standards Institute. In addition to these roles, in 1997, the RMI issued a specification for storage rack, which later was updated to become the 2002 edition, and more recently it's adopted by the American, ANSI MH 16.1 2004. But shortly after the 97 spec, the RMI created the RMARC certification program as a way for storage rack users and customers to clearly identify that rack frame and beam capacities that were shown in load tables were calculated in accordance with the new standards. So those being the load tables, let's say, provided by the manufacturers that you would see in the literature. The RMI has also done significant research and testing in the area of seismology as it relates to storage structures. We know Mother Nature, is unpredictable, and at any given time, earthquake or similar seismic activity could impact equipment that's within a warehouse. And most recently, we've developed an extensive educational series and marketing campaign to raise awareness and promote best practices in warehouse storage systems, and of course, enhancing the safety of the workers in these environments. This webinar today and videos that we've released or will be releasing in 2018 are part of that initiative. So let's move on to the next slide. So how would one define an industrial steel storage rack, which falls under the description of our product, also commonly referred to as pallet rack, although we know it's not just used for palletized goods? Well, it can be described as a multi-level steel storage system to support the high stacking of single items or palletized goods. Now, it's utilized in just about any type of facility seeking to maximize space, but also product access, whether it be in manufacturing to store raw materials, in warehousing and distribution centers, and as I mentioned earlier, even commonly found in public big box stores and retailers of all sizes today. Racking systems are a fundamental component of any distribution, storage, or material handling operation. But the right racks also allow rapid access to stored materials and certainly maximize the facility space while simplifying inventory requirements. Now, when we look at a chart that we see here, you're looking at load weight characteristics and all the dimensions, which are critical so as to ensure the proper application and clearances. But there's some things that are obvious and some things that are not. The type of material handling equipment that's being used to transport and store the materials will help to evaluate the density of a storage system and its capabilities. And if we were talking about pallet rack in particular, those loads or goods are going to sit on a pallet. And I'm just going to touch on, some of the elements here. There's a lot of information that we're going to not cover, but again, those are available in the other resources. So the most common 48-inch deep by 40-inch wide pallet that most of you encounter, or what we call the GMA, Grocery Manufacturers Association pallet. Now that's defined really as a pallet with 5 bottom boards. It's got 7 boards on the top, and with food products representing the most widely consumed commodity to require transportation and mass storage, the GMA was responsible for developing that standard back in the 60s. And that addressed uniformity and the unitizing of loads. They wanted to make things relatively standard. We've all benefited from that very, very standard pallet today. And as a result, this helped to drive the popularity of certain pallet rack dimensions that we see today in the 42-inch deep frame, as well as the 96 and 144-inch long load beam, all based around the dimensions of the depth of the pallet, 48 sitting on a 42-inch deep frame, so you have the proper overhang clearances, and of course the proper clearances left to right on the load. We're going to talk about some of those other clearances in a minute. But selecting the frames and beams, there's a couple of things that people tend to overlook. And the effect of beam spacing and frame capacity from a safety standpoint is so critical. The RMI helped to establish a guideline by suggesting a 48-inch vertical beam spacing as the norm to reflect on published manufacturer capacity load tables. So one of the most critical steps in selection, yet too often are ignored or misunderstood by those that are buying or procuring the racks. And those who just request a profile size or don't provide the capacity based on the actual beam spacing are doing a misuse, or they're completely ignoring the actual reality of how a frame holds its capacity. So as an example, a frame that may hold 21,000 pounds based on the chart at 48-inch beam spacing may only hold 15,000 pounds if the vertical beam spacing is 72 inches. And that's just one example. So the load charts need to really be reviewed and properly applied when selecting a frame. On this chart, you'll see that it says upright height 1-inch increments in the middle there. Just be aware that it depends on the manufacturer's product. Many of them have a 2-inch increment. You can achieve 1-inch increment, with certain racks and with certain beam connection welding and so forth. So spacers are recommended for all back-to-back upright rows. and usually with a minimum of 2 required. However, more are required as the frame heights rise over 20 feet. And that's, of course, to add stability and integrity to the system. But you always have to check with the manufacturer's recommendation. And speaking of height, on single rows, it is not the ones that are back-to-back. It is critical that no more than a 6-to-1 height-to-depth ratio be maintained from floor to the top load beam. Or that row, that single row, will require support from the adjacent rack row, or possibly even just larger base plates may address that. And I want to continue on with some clearances here, because when planning a warehouse, clearances around the load are important, but not just for product placement purposes, also to conform to today's codes, specifically NFPA fire protection codes, where a minimum of 6 inches in the down aisle direction between the loads and the uprights is required. But once again, refer to the codes for proper adherence, and there's a lot of manufacturers, or there are certain manufacturers that manufacture these special items that will help to maintain those clearances. But of course, no one wants a fire in their warehouse, yet they happen every year. And to support the development of better prevention measures, the RMI participates in the NFPA committee that's responsible for the creation and revision of national standards that are specific to the safe design of sprinkler systems. All right, so let's, I just want to talk about local codes for a minute. And we can stay on this, this slide here, because it'll certainly be relative as well. So how would you know if a building permit for a rack system is required? Well, rack structural systems, not unlike building structures, are often subject to the building code review and permitting process. The pertinent building code, usually required by a municipality, county, or state, but occasionally local requirements may differ from the more generally applied national or international building codes. So the user should determine from the local authorities which building code is applied, and then report that information to the rack supplier or rack manufacturer. But the materials required for a building permit normally include a little bit more information than just what components they are. It's the details of the proposed rack and its use, the various loads for which it's been designed, the calculations from an engineering analysis, along with sealed drawings by a registered design professional that demonstrates the structural integrity of the system. Sometimes even the details of the fabrication and the installation, because the building may also include relevant information about the characteristics of the floor slab and the building structure if you're going to be connected to it. Next slide, please. So how do I know if my rack system will require a design review to account for seismic forces? Well, the specification today utilizes what we call a spectral response design map, like the one shown here, that reflects seismic hazards on the basis of contours. And these maps were developed by the USGS, the United States Geological Survey. The areas in the seismic design category B and above face the potential of earthquakes to varying degrees, magnitudes, and probabilities. But areas in seismic design category A do not have enough really seismic activity to warrant a design check for that case. So you really need to specify where that location of the warehouse or facility is going to be, and we'll get into that more in a second. So you might be asking, well, what happened to the old seismic zones of 0 through 4 that many of us were aware of for years? Well, that zone designation is no longer used, and that occurred with the introduction of the International Building Code in 2000, which also affected the ANSI RMI MH 16.1 specification that I referred to before. So the old zones fell under the UBC seismic evaluation, which was the Uniform Building Code. And that was based on seismic ground motion corresponding to certain probability of occurrence within a zone. So therefore, all the structures within those general zones were designed for the same requirements. But the building codes today are now reinforced or now referred to as seismic design categories. So today we use the SDC method, which range from A to F. And a function of that seismic hazard at the site, the specific site, the type of buildings or occupancies built at that specific site, and the soil data at that site. So it's more representative of very site-specific characteristics. But again, it's important for the user to bring to the attention of the rack manufacturer or rack supplier the specific local installation, the actual address by zip code, or any knowledge of the supporting concrete slab that they might have. So thus rack systems really need to be designed, manufactured, installed, and used in accordance with the site-specific requirements of a given location. Next slide, please. So here's where retaining the services of a material handling equipment specialist is so necessary in determining within the budget allotted what forklift and rack type will yield the best solution. There's a lot of choices, right? And combinations, and they're quite varied, and they all have their advantages and disadvantages. And I'm not really going to get very specific here because, again, there's so many combinations, and the important thing is knowing the equipment, once it's selected based on the budget allotted and the space allocated, the clearances of the aisle necessary for that specific piece of equipment are so critical to making sure that there's a minimization of rack damage and other safety elements in terms of how a forklift operates within the confines of a rack aisle. So it's really up to your rack specialist and the user to determine what forklift and what height the racks are going to achieve, but then most importantly, designing the system so that the proper aisle and clearance are incorporated. The literature of forklift equipment very clearly states right angle stack dimensions, and it's usually recommended that you add at least 6 inches for ease of operation. Okay, so let's move on to the next slide. Now, putting it all together with accessories, where there's such a myriad and variety of all different kinds of everything from impact protection, safety-oriented components, to the ubiquitous wire decking that's used today so often to support loads in the event that pallets are compromised or are not in the best condition. I'm not going to get into all the different accessories. There's certainly, you can find them in a number of different resources. We just give you an illustration here of some of the many safety-oriented items available to the users. Okay, next slide, please. This next topic, very, very critical. We've seen, or I've seen, and many of us in the industry have seen installation of rack done by end users, done by less than capable people, because racking can be put together quite easily in terms of its design. But the installer capabilities, the company selected to install a rack system should really be experienced in the installation of that specific type of storage rack system that's going to be installed. And within that installation group or that contract, there should be an experienced foreman that should be assigned who can supervise the workers, but also have the necessary expertise to install the rack in accordance with the installation instructions that are going to be provided or should be provided by the rack specialist or manufacturer. And installation drawings, of course, involve a number of things which I'll get into. But the rack installer should have access to the rack manufacturer's resources, whether on the web or through literature or those drawings, as needed to support the installation effort. And any questions or concerns related to the rack installation should always be brought to the attention of the project manager or the manufacturer for clarification or resolution. Let's get into the next slide. So part of the responsibility of the end user is, and the actual rack specialist involved in this project, and the manufacturer. In industrial and commercial facilities, allowable floor loads are generally posted in easily visible locations, and such postings are often required by law. But when it comes to the rack systems, the RMI and ANSI specification provides for a similar type of posting, showing maximal permissible loads, unit loads in one or more conspicuous locations, usually at the ends of the rows, for each given rack installation. You might have different elevations in different rows. And the intent of the plaque is to inform persons in the facility of the safe capacity of the rack installation. So a typical load plaque might look like the one that's pictured here, because they really are provided from a number of different sources. The owner of the storage facility, the end user, is responsible for being aware of the load limits and to instruct all personnel involved in that facility that are using or that work near the racks to assure that they know what the maximum permissible load is and that it not be exceeded. The load plaques post the load limit for a load shelf and in some cases the entire rack bay. But it's the rack user's responsibility, again, I don't want to stress that, I can't stress that enough, to obtain and display the load plaque. All right, so rack installations must have drawings as well and other suitable ways of documenting the various permissible rack configurations for each installation. And this frequently is done with one or more drawings that show the components and their locations of the system. So of particular interest is show all the shelf elevations and corresponding maximum load weights for each bay and elevation. And these drawings, by the way, are called LARC in our industry, load application and rack configuration drawings. And these drawings must be retained by the owner for the life of the storage system. Next slide, please. So, operator training, but in particular, all personnel who will be working in and around the storage racks and the material handling systems must be trained with regard to the safe operation and use of racks and other material handling equipment. So, forklift drivers must be properly trained and qualified on the correct and safe operation of the fork truck that they're expected to operate. If a new or different type of truck is introduced into an operation, that driver obviously must be trained on the correct use of that particular type. Now, order pickers, the types that bring operators up into the actual rack system or man-up systems, or other personnel that are working on structures that are above grade, must understand that fall protection systems are provided for their safety. All right, let's move on to the next slide here. So when it comes to OSHA's involvement, which really is quite extensive when it comes to the operation of forklift equipment and so forth, OSHA is known, of course, as the Occupational Safety and Health Act from 1970. It's Congress created the Occupational Safety and Health Administration to assure safe working facility. And OSHA is part of the United States Department of Labor. However, OSHA really only has a relative documentation involving storage racks. Very limited. It really, in regard to the proper stacking of product on a shelf or pallet, so as not to create an interlocking pattern or minimize the dislodging of these goods during transit or storage and retrieval. But I welcome you to certainly read up or research a little bit more about OSHA compliance when it comes to your specific application, especially as it relates to the motorized equipment that might be used in that environment. So I'd like to turn over the presentation at this time to John Crummell.
Okay, Nelson, thank you very much. This is John Crummell with Advanced Storage Products. Now, we've got our new system. We've got a nicely engineered system, all installed properly and meeting code. The key thing is long-term, we want to make sure we're providing all of our team members a safe working environment. And what we all have to remember is that when a rack system gets damaged, it will reduce capacity. Doesn't matter how much damage. Even if there's a little bit of damage, there's going to be a little bit of capacity reduction. And without doing an engineering analysis, it's hard to tell how much capacity has been reduced when there is damage. Another key thing is I struggle when I have customers who say, well, we don't have the budget to repair the rack this year. And it's hard for me to put a price on safety. So I think when people look at it, you have to look and say, is it really, can we really afford not to provide provide a undamaged rack system in a safe working environment? And the third key thing to remember is, as we're doing this, make sure you're working with professionals, work with people that know rack systems, someone who has the engineering background to understand what is safe and what isn't. Now let's go to the next slide. Oops, we're one slide off. One more slide, please. Now let's take a look at what can happen to systems when you do have forklifts interacting. A forklift moving 10 miles an hour can do a lot of damage to a rack. And you can see where the far left, they've taken almost completely taken the frame out. And what's even more of concern to me is you can see there's still some pallets sitting on that level there. So if you see damage like this, you need to unload the rack right away. I hear it hasn't fallen down yet. You got to unload it. You see the next one, they've taken the middle, they've taken the column out in a couple of cases. They've crushed a column down below. In all of these cases, you need to unload the rack. And you say, well, if the rack hasn't fallen down yet, why do I need to unload it? But what happens is if you go and you damage this frame, the way that a rack system works is the load that frame was supposed to carry gets transferred to other members of the rack system. So it'll go and get transferred to the frames next to it or the frames behind it. And then those other frames are carrying an extra load that they weren't designed for. And then let's say somebody damages the frame next to it, then all of a sudden the load gets transferred to other frames, and at some point the system can collapse. And a rack collapse is catastrophic. And if you're having someone in an aisle when a rack collapses, it can be fatal. So the key thing is, if there is damage, you need to unload the system and get it repaired. And there really isn't, unless you have engineering dispensation, it's very hard to go and say that that's not enough. It's not damaged so much, so it must be okay. Let's go to the next slide, please. Okay, so let's talk about what we're doing when we're doing our inspections and maintenance. From a guideline, RMI publishes a rack repair guideline that we put together a couple of years ago to give a good outline of what to do when you're repairing or replacing a rack system. The RMI rack website is up and running. That's updated on a weekly basis, and it's geared more towards the users with some general guidelines. It's not as technical as the guideline is. So the things that to look for, the first thing is you got to make sure that the rack is configured the way it was originally designed. Has somebody changed the design? Has somebody moved beams around? Has somebody changed components? Make sure it's what was originally engineered. Also make sure that the load plaques are installed. That's a good way to tell, is this an engineered system? If the load plaques aren't there, I would contact the supplier of your equipment, either the OEM or the distributor, and have load plaques designed so you can get them out on the end of the rack and make sure that the rack matches up with what the engineering was. So the first thing is start looking for damage. Is there damage to the frames and the bracing? Have anchors been sheared? A sheared anchor, the anchoring is part of the rack design, and so if the anchoring has been sheared, you need to put new anchoring back in. Are the beams in place? So the locking device has been knocked off. Are the rifle bolts installed? Is hardware missing? Is it loose? Are there support components under the pallets? Are the accessories in place? You'll see crossbars that can be knocked out of place and the pallets aren't supported properly. Is the rack aligned? Is it standing straight? I mean, I've seen rack leaning left and right, and people haven't corrected that. Are the pallets in good shape? Sometimes people will go and put, C quality used pallets on it, and you could have a pallet collapse happen and the load could come out of the rack and land on somebody. Is the rack rusted or corroded? Has it been stored outside? Has it been in some sort of a wet environment and you could get corrosion to weaken the steel? People look at some other things and some unauthorized repairs. If people tried to, maintenance guy tried to fix the rack using what, common sense, but it may not be safe. And another thing we'll talk more about is mixing and matching rack styles. The rack is really designed to be intermembered typically with just the other components from that manufacturer. So let's move to the next slide, please. Okay, so rack does get damaged. You can see here a frame, somebody clipped it with a rack, with a forklift, and took the column right out from underneath the load beams. Now again, as we said before, make sure you unload that frame on both sides of the frame so that because right now it's lost all its load-bearing capacity, and if you do keep load on those frames, it's going to get transferred to other parts of the system. Now, one of the things that we see is that if you don't keep up with the repair, if you say, well, we'll get to it next year, it tends to get worse and worse and worse to the point where you get so much damage you don't really even know where to start. So that's why it's very important to go and keep, every couple of months, if you have a high throughput system, make sure you're going through and just getting the damage taken care of as quickly as possible. In some cases, we've seen as much as 10% of the rack getting damaged in the course of a year. And so it can be a serious issue. And if you let it get out of control, it's very, very hard to catch up. Now, a lot of different factors can affect the damage. The inventory turns. If it's a high throughput warehouse, you have a lot more equipment running through it, and it can damage the rack. If you're using equipment that may be a little bit tight in the aisles, you can get a lot more damage. A lot of times we'll see people will try and go to the very minimum aisle width allowed for with a piece of equipment, and they tend to back into the rack a lot as they're rotating in and get a lot of damage from that. We'll see that a lot on lower load beams that get hit. If you have a real high throughput warehouse and put in a unreinforced roll form system, that may be a system that's subject to a lot more damage too. We'll see in the really high throughput systems, they'll tend to put spend a lot more, fair amount extra to put in highly reinforced rack so that it can take the impacting from the equipment. Another thing that can also really affect the damage is turnover. If you have a lot of new employees who aren't well trained and they don't know how to use the equipment properly, the newer employees are going to tend to cause a lot more damage to the rack than more experienced folks. So let's go to the next slide. So let's take some things that can happen. So the first picture over on the left is showing a very creative repair job done, I think, by an employer's maintenance department. And there are a bunch of things that are wrong with this. First, there's no way that this is an engineered repair. There's no way that an engineer would ever sign off on that type of work. The field welding, we highly discourage because most welders are not certified to do the types of weld that you see in the field. The other thing that happens is a weld like this, they probably didn't properly clean the weld ahead of time and get all the paint out of the way. If you weld through paint, you can contaminate the weld, and the weld you can get what's called hydrogen embrittlement in the weld. So we strongly discourage the field welding. The next one over, you can see a strut is missing right there, and it looks like there may be a bottom horizontal missing right in behind it. You say, oh, it's just a strut, why do I care about that? Well, the rack system, the load has been reduced, and without doing an engineering analysis, we really can't tell you how much that load has been reduced. So in that case, our recommendation is you unload the frame and put a new strut in before you reload the frame back up, unless you have an engineer who's done the calcs to say it's okay at a certain level of loading. Then the third example, you have a bent strut. In this type of case, you can typically bend it back, and that's not as severe as the other issues that we've shown. But again, have a guideline, work with a qualified engineer, and work under engineering guidance as you're running your rack safety program. Next slide, please. Now here's some other issues. You can see on the left, you have a load beam that's backed into, and this is common when we see aisles that are too narrow and they rotate out of the aisle and they back into the beam like this. In this case, the beam needs to be unloaded, taken down, and replaced. That's really something that's not repairable. The one in the middle, you can see corrosion starting to eat through the paint. Now, if you just have a little bit of surface rust, that's not really a big issue. It's really just when it starts to eat into the core metal itself, and if it starts to actually cut through the metal, then you can have larger issues. And then the third picture over on the right, you can see that this is a homemade repair kit where you've got a rack that's damaged above the repair kit. You have a repair kit that somebody made out of, I don't know what they made out of, and then created a slant leg on top of it. And in a case like this, you just would immediately unload it and replace the frame, or put in a kit that's a pre-engineered kit made by a qualified manufacturer. So these are the types of things that we see in the field all of the time, and any one of them can result in a safety concern and ultimately result in a collapse. Next slide, please. So how often, when do you do your rack? It really becomes part of the normal operation, just like you go and do normal inspections on fork trucks, or you take your car into the dealer. Rack systems are no different. It's a capital item. They do get damaged. You do need to repair them. At a minimum, we would recommend an annual inspection for a low velocity system that doesn't get a lot of damage. But if you have a system with a lot of velocity, a lot of turns, quarterly might make more sense, or even monthly if you have a system that has very high throughput. And we'll see that in the grocery warehouses, that often they'll inspect monthly just because they have so much activity in the warehouses. So it really depends on the site and the type of rack system you have in place. Next slide, please. Now, one of the big questions that we get is, should we repair or replace it? So there's some in a lot of cases, it's easier just to replace a component. If you have a damaged load beam, for the most part, it's just easier to replace it. You just take it out, have a new one come in from the manufacturer, and put it back in. The frames are the harder part. Most of the time with a shorter frame, if it's 20 feet, it's easier just to replace it. But a lot of times you might have very tall frames where they're 35, 40 feet tall. You have in-rack sprinklers, you have very heavy components, and it may make more sense in those cases to bring in a pre-engineered repair kit. And those types of systems you can buy from OEMs. There are also other qualified manufacturers who make repair kits, and those can be done. At times, those make the most sense. And it really is on a case-by-case basis, a system-by-system basis. But the key thing is make sure that whoever you're working with, be it a distributor, an OEM, or a rack safety company, that they have engineering, that they have qualified engineering backing up the design. And the engineering isn't a generic engineering. It's not that the repair kit is okay, it's that they're certifying that that system is okay. So they're saying that if I put that repair kit onto this rack, that rack system is okay now as a whole, so that it's all the rack that's being touched by the repair. Next slide. Now Nelson addressed a little bit about it on configurations. Now I remember a story I heard where the operations manager decided they needed to bring taller pallets into the system, so they said, let's go and take the bottom beam out of the system. So they took the bottom beam out of the entire system. What they didn't realize is I think it was only a 2-beam system, so there was only 1 beam above that, and the whole system collapsed. So it's very, very important anytime you're reconfiguring a system, especially taller systems, that you go back to the original supplier of the rack, or you bring in a qualified engineer and get updated drawings. And people have asked me, they've said, look, John, you're an engineer, you've been in the rack industry for 25 years. Can't you just look at the rack and tell it's safe? And tell me it's safe? And it's just, I really can't. There's no way. I mean, if somebody asks me to look at a rack system, the first thing I do is I look for the load plaques. Are they in place? Okay. If they have load plaques, does the configuration match the plaques? Okay, the configuration matches. Now we can start doing a damage inspection. But if we don't have the load plaques or don't have drawings to check against, then you really are guessing until you go through those steps. And the key thing, like Nelson mentioned before, is any change in beam elevations will change the capacity of the system. It may be for the better, it may be for the worse, but it's important to make sure that you're working underneath engineering guidance when you do that. Next slide, please. Now, one of the issues we have is we talk about, in the US, most of the roll form rack is teardrop configuration, and people say, well, isn't a teardrop configuration the same for everybody? And the reality is that the teardrops and the load beam clips are all engineered slightly differently. And so when you're mixing and matching the beams from one manufacturer to another, it's very important to make sure that they're fully compatible, because the centers of the studs are slightly different in a lot of cases. And a lot of times they haven't done the testing on the intermembering. So if you're taking something that is made by rack manufacturer A and putting it into rack manufacturer B, it may look okay to someone who isn't a qualified rack engineer, but in reality, the parts really don't fit together properly. And some of the largest collapses that have happened have been when people have started indiscriminately intermembering different rack systems, and it looks okay on the surface, but they didn't realize that they were putting 2 incompatible systems together, and it just puts people at risk. So when we do intermember, at Advance, we do intermember with other rack manufacturers. When we do it, we actually test. We'll go out and get some of their product and get some of our product and put it together and send it to the lab and make sure that it's fully compatible before we do any repair work to an existing system. So it's just very important that you're working under engineering supervision and be very, very careful about the intermembering. And then when you do if you do a reconfiguration, make sure you get new drawings. Best practice to have them stamped. It's not necessary, but it's a good practice to know that you have a good qualified engineer working on it. And the key thing is if you follow all these steps, you will have a safe rack system. But by skipping steps or making assumptions or saying, I've been around the industry for many, many years, it puts things at risk, because you can overlook something and end up with a collapse. And if you look at the system on the left, I mean, that's a 40-foot tall rack system. 3,000-pound pallet falling from 40 feet is not something you want to be anywhere near.